Okay, thank you very much, Carla and Carlos, for this presentation. We really appreciate. We really want to know more about Lightning. I think it's one of the really huge technological structure or infrastructure that people sometimes don't know too much about that. But it's having a lot of development in games, in a lot of payment. So it's really, really amazing how it's evolved. So we really appreciate that you can really give us an overview of that. Carlos, I let you because you are the expert in Lightning. I know that you have been playing games 5 minutes ago with people. So that's a reality right now. So thank you very much for both for staying us and to can introduce or to do an overview of Lightning. Thank you very much.
Cool.
Yeah, so, thanks for having us.
Yeah, thank you. Yeah, so well, it's a pleasure to be here, as always, Jesus, and it's a pleasure to meet you, Carla. So yeah, let's start. So well, we've been talking a little bit about Lightning Network, how it's gonna be this presentation, and how it's gonna be delivered. So we've been well, I think Carla, you have prepared some slides, so you could start doing some introductions, right?
Yep, I can start now if you're ready. Are the slides visible to everyone? I assume they are.
Sure. Yeah. Let's go for it.
Great. Cool. Well, thanks for having me on this. It's always good to walk through a bit of Lightning stuff with people. My name's Carla. As they've said, I work over at Lightning Labs, where we produce the L&D implementation of the Lightning spec, as well as some other tools that make it a lot easier for people to operate businesses and routing nodes on Lightning. So a quick walkthrough of what we're going to cover today. I'm going to walk through a brief Lightning 101 just to get everyone up to scratch on the fundamentals. Then I'm going to talk about some payment improvements we've recently made to the network, followed by a bit of progress in the Light client field, and then to close off, look at some future changes that we hope to see in Lightning going forward in the longer term. Right, so Lightning 101, I'll try and keep it brief for people who are familiar, but for those who aren't, really what the Lightning Network is just a network of payment channels. And where a payment channel is just a amount of funds held in a Bitcoin multi-sig address. So say we have two people who run Lightning nodes, Alex and Brian, and they want to open up a payment channel between the two of them. One person puts forward funds, so say Alex decides he wants to put 5,000 Satoshis in a channel. They then sign a multi-sig controlling these 5,000 Satoshis. And this means that this balance is now controlled by Alex and Brian. Neither of them can spend it without the other one consenting to the amount that's being spent. And what they do with that 5,000 Satoshis is they then create what's called a commitment transaction, spending from this multi-sig. And really the way you can think of a commitment transaction is like a set of balances between two people. So when they start out, Alex has 5,000 Satoshis because he opened up the channel, and Brian has none. And at any time, either of them can broadcast this commitment transaction and claim the money they have on chain. However, the great thing about Lightning is that they can use the signed commitment transaction to shift funds back and forth to make payments between the two of them without ever needing to go on chain at all. So take the case where Alex wants to pay Brian 1,000 Satoshis. All he has to do is sign a new commitment transaction that shifts 1,000 Satoshis over to Brian and only pays him 4,000 Satoshis. And in that way, he's managed to make a Bitcoin payment off-chain with absolutely no on-chain footprint besides the original channel opening transaction. And the way that they do this is by signing new commitment transactions, which reflect the new balance between the two of them, and revoking the old one. So the one that paid Alex those 5,000 Satoshis now can't be broadcast because then Brian can punish him, which is a quite complex mechanism. So I'm not really going to go into it. But the key to take away here is that this is a trustless relationship and no one can go back to an old state. And what's great about this is they can continuously shift funds back and forth in this channel. So they can send as many payments as they like back and forth between the two of them. All they need to do is be online and update this commitment transaction. Now, another way that Lightning achieves scale beyond an individual payment channel is through using multi-hop payments. Now, take the situation I've got here on the screen where Alex has a channel open with Brian, but Brian has a channel open with Connor. And Alex could open up a channel with Connor to make a direct payment to him in a payment channel, but that would mean he would have to open the channel on chain, he would have to pay some fees, and he would have to wait for it to confirm. So instead of doing that, what Alex can do is send 2,000 Satoshis through to Brian, and Brian will send 2,000 Satoshis through to Connor. And what they've managed to do here is send 2,000 Satoshis from Alex all the way through to Connor without actually having to open up a payment channel at all. And the key here when this payment is made is that it is atomic, which means that Brian can't just take Alex's 2,000 Satoshis and say, thank you very much for the money, and not pass it on to Connor. And it's also trustless. So no one in this line of nodes needs to trust each other at all, which means that you can route payments through complete strangers in the Lightning Network. So that really allows us to achieve a lot of scale because we have thousands of channels open and your node has a view of the entire network. And provided there is a string of channels between you and another node, you can make a payment to them. Right, so building on that foundation, we've had some recent upgrades to the way in which we do payments in Lightning, which I think is going to be great, not only for success rates, but also for improving the amount of volume that the network can process. So the biggest change, and it is quite literally the biggest change, is the addition of what we call wombo channels. For those who aren't familiar with the study of wombology, this is lifting of the limits of the size of channels that you can open in the Lightning Network, which was previously 0.16 BTC. Now, this change is opt-in and it is behind a bold tag. So if you don't feel ready to open up larger channels in your Lightning node, there's nothing that you need to do. And if you are opening up wombo channels, I would advise people to follow best practices and scale the number of confirmations that your channel needs with the amount that you're going to put into it. And of course, this has the effect of being able to facilitate larger payments in the network, but also has the slight side effect of decreasing the burden that people who operate Lightning nodes need to carry. So at the moment, if you were wanting to process huge volumes on Lightning, it wouldn't be very easy because you'd need to open up lots of small channels and then keep track of all of them and pay fees for them. Whereas with Wombo, you can more easily open up a large channel and perhaps decrease the complexity of your setup a little bit. Something else that's really great for payments, and I think is going to make a really large difference, is that MPP payments are here, which are multi-part payments. And really what this means is that instead of making a payment on Lightning with a single route, you can make it using multiple routes. And the difference that this makes is that before this change, you were limited by the smallest channel between yourself and the person you wanted to pay, whereas now you are limited only by the sum of balances from yourself to the receiver. And what's really great about this change is that it also only requires sender-receiver upgrade, which allows us to roll out a lot more quickly. So in the case where you're routing MPP payments, so long as the person you're sending to has upgraded, it doesn't matter if the nodes in between know nothing about MPP payments. It'll look the same to them and they'll still be able to forward the payment for you. To explain a little bit how this works, looking at a similar node situation where Alex has a channel with Brian, and Brian has two channels open with Connor, both with 2,500 Satoshis in them. Before MPP, Alex would need to make this payment to Connor in a single shot. So say he wanted to pay Connor 5,000 Satoshis, he would try and send a payment of 5,000 along the first channel and then 5,000 along the second channel. But the second channel only has 2,500 Satoshis in it, so that payment would fail because there's not enough balance. Likewise, he'd go back to the drawing board and try again, sending 5,000 on the first channel and then 5,000 on the second channel. But because this one is also less than 5,000, that payment would fail. Now, this is not the case post MPP because Alex's node can have a look at the channels and more smartly decide how to send this payment. So what he would do in this case would be dispatch one path with 2,500 along his first channel and 2,500 along the second channel. And this time it would be able to accommodate it because it has that capacity. But then to make his 5,000 total, he would actually dispatch a second set of HTLCs from Brian to Connor. And in this case, because all of the channels combine to equal the amount of the payment he wants to make, this payment will succeed. And they'll be able to shift the balance from Alex to Brian to Connor, even though it needs to be split over multiple channels. Now, payment splitting in the wild is not as elegant as the example I've given. This is a new change, and there's a lot of experimentation to be done, deciding how we split up these payments. One of the big considerations here is that there is a trade-off between the number of parts that you split and the fees that you pay. So taking the example that I just gave, although Alex would be able to complete the payment to Connor with 4 HTLCs, each one of these would bear a fee. And in Lightning, we have what's called a base fee, which is charged per HTLC, as well as a fee rate, which scales with the amount. And at the moment, a lot of nodes have quite high base fees. So if you start to split up into too many HTLCs, the fees can start to add up. So what we do with this in LND at the moment is quite simple. We split up into equal size HTLCs, and we set a maximum number of splits on those HTLCs so that you don't spiral off and end up paying way more fees than you would want to. And this max number of splits is exposed on LND's API. So for those who are running it, have a look at the send payments v2 endpoint and play around with it a bit. We'd love to get some feedback. It is quite interesting to see how these larger payments are working out right now on the network. Moving on to light client support. This is particularly interesting in the field of gaming. But for those who are unfamiliar with Neutrino, if you've ever run a Lightning, non-custodial Lightning wallet on your phone, or perhaps a game like Bitcoin Bounce, then you are likely using something called Neutrino. Now, this is technology which allows mobile clients to operate without having to set up your own Bitcoin node, which is really great for getting people onboarded very quickly and for decreasing the amount of hardware and bandwidth that you need for your node. And the way this works is using filters to get information about transactions and blocks, which you then use to inform your Lightning node. The great thing about Neutrino filters are that they are privacy preserving. So the nodes that you query to serve you these filters don't actually know what you're looking for, which is important in Lightning. And they're also a lot more efficient than their predecessors, which is something called Bloom filters. Previously, these Neutrino filters were only supported by an implementation called BTCD, which is a Golang Bitcoin node. And not a lot of people run this because it is a more experimental project than Bitcoin Core. So what this meant is there were fewer nodes on mainnet actually serving this filter, which made it a bit more difficult for Lightning nodes to sync. However, we're really happy to see that opt-in Neutrino support has recently been merged into Bitcoin Core. So hopefully in the future, there'll be more nodes serving Neutrino, which means it'll be much more easier to sync up a mobile node. Speaking of the future, some future changes that we hope to see in Lightning in the longer term. The first one is atomic multipath payments. So these are similar to MPP payments in that they have multiple paths. However, they differ a little bit because they use a distinct payment hash per path, which provides better privacy. Don't worry too much about what the payment hash is. Just know that they have a slight privacy improvement. And a subtle difference with these payments is that the sender derives the pre-image, which is a secret used to transfer the value in the HTLC. But this does have the downside that you don't get a proof of payment, whereas in a regular Lightning transaction, the person you send to who receives the payment unveils the secret, which you can use as cryptographic proof of payment. But the really great feature that these do provide is recurring payments, which I think is an incredibly exciting thought on Lightning. So you could receive a single invoice for a Lightning-based subscription, and every month or every day or every minute or whatever you choose, interval you choose to pay it, you could just push payments to the subscription. And I think it's really interesting that these will flip the subscription model from having 15 different things that are randomly pulling from your credit card because you once signed up for a free trial in the App Store to actually being able to push payments out to services and decide exactly when you want to cancel, which is really great. Something that's even further afield is dynamic commitments. Now, I will give the disclaimer that these are pre-draft. So all there is right now is a proposal on the mailing list by Lalu. But I think these solve a really important problem in Lightning, so I thought I'd bring them up. And what they do is address the upgradability of that commitment format. So that thing that we sign, which agrees on our balances, has a certain structure. But there are various reasons why we might want to change our commitment format. Looking forward, this could be something like the addition of Taproot to Bitcoin Core, which we could then upgrade Lightning to use Taproot and take advantage of the privacy benefits. We could look at something like L2, which changes the way in which we penalize Lightning breaches, or we might need to have some security fixes in just the way that this commitment is structured. And the way that this would work is actually quite simple, which is also really nice. So you'd simply suspend the use of a channel for a brief period of time when you want to upgrade, exchange a new set of commitments that use this new format, and then continue on with a new format with no on-chain footprint. And this is really important because it allows us to apply a network-wide upgrade without mass closure of channels. So at the moment, if you wanted to change our commitment format, say upgrade to Taproot, every channel on the Lightning Network would have to close, and then every channel would have to be reopened. And that would be a huge number of on-chain transactions, a huge fee spike most likely, and it would put a lot of pressure on people not to upgrade because they don't want to pay those fees. So although this is only in draft state, I think it's a really exciting thing to look forward to. Oh, and that's it. Thanks.
No, well, thanks to you. It's a very impressive slide. It's been very refreshing to have this information here again. And yeah, I have some of the questions to go through. Well, I think if the community watching is right now live, if they feel like they want to do some Q&A and questions, Carla's here to as well provide some answers in the side. Regarding the dynamic commitments, it's interesting the way it's been. The actual channels are being very modularized in a way where you can isolate them and bring them more upgradability features, right? So this is kind of what is I would say one of the most interesting factors of dynamic commitments will be the isolation and upgradability of single channels, independently from others of the same node, right?
Yeah, absolutely. So individual channels in the network can start to upgrade. What I think is really cool about Lightning is because there's kind of the separation between channel level and routing level policies, you could upgrade a single channel to Taproot, but people who haven't upgraded around you could still route through because it's no concern to them how you use that one specific channel. So it's really great in allowing individuals who want to upgrade to do so very easily. And you know, it's very difficult to get people to upgrade anyway. So telling someone that they need to pay on-chain fees to close and reopen, I mean, even me, I'd say, guys, fees are high. I don't know if I want to do that. But if you give people a really easy option, which would theoretically be a few seconds of downtime, if even, just to upgrade to Taproot or to a different commitment format or a security fix, I think that's really huge.
That's very interesting. Thank you, Carla. So for Taproot specific upgrades that bring some Bitcoin privacy for, in this case, routing payments through channels that they've been activated through the dynamic commitments, how will a node, well, it's a very pre-draft, but in your opinion, how will you envision a node operating in different scales, one with Taproot activated channels and the other one without them? I mean, in the same sense as if you can put the two type of channels, how do you envision the outperformance?
Well, the format of our current commitment transaction versus a Taproot one would actually be fairly small in terms of changes. I think Connor, actually, one of our head of cryptographic engineering over at Labs, has a very old branch upgrading to something quite similar to Taproot that he wrote about 3 years ago. We've just been waiting for activation ever since. But it would just be that the commitment transaction would use tap script rather than SegWit v0. So at the moment, we pay to witness script hash, and we would upgrade that to pay to taproot script hash. I think that's the latest name for it. But the big difference would be that in the happy case of a Lightning channel being resolved, which is a cooperative close, it would look like any other pay to address payment on the network. So at the moment, it's somewhat easy to detect Lightning channels that close because most people who spend from a 2 of 2 multi-sig are closing a Lightning channel. Whereas now this would just look like another send to another Bitcoin address. So in the good case of closing out, it would really enhance privacy. And in the unilateral case where one party closes out, it would be the same in terms of privacy.
Very interesting. Okay. Interesting. So yeah, now going to the actual topic of AMPs, the atomic multipath payments, that brings along those recurring invoices, which are a shift of the actual paradigm of the invoice payments. So with pool payments or recurring invoices, it's something that we can create new business models out of this infrastructure to have something recognized as pay-per-click services based on subscriptions.
Yep, absolutely. I think there's a huge number of use cases that it opens up. But I think one of the most important things about AMP is that it makes it quite easy for people to build on. So you could theoretically write subscription service right now in Lightning, but you would have to reissue an invoice every time you want to pay that subscription. And the payment is still push in that model, but it's a lot more work if you are a service trying to push out these invoices to your customers every month versus issuing a single invoice and sign up. You know the unique identifier for them, and they can just push the payments every month. If the payment stops, the service stops. So I think it's a lot more of a simple model to build on, which is always a great catalyst for great ideas and features.
Interesting. So yeah. So well, I have more questions, but let's give the community as well some answers. So here in the comments chat, I see that some users are asking, how can the Lightning network scale? So how Lightning networks can scale by design?
Well, I think that the real scaling issue that Lightning faces right now is that the way in which we revoke commitment transactions. So right now, when you revoke a transaction, commitments or estates, you do so by giving your peer in that channel a transaction that they could use to claim all of your funds if you broadcast the old state, right? And that means that for every single state that you log in, you also need to keep the previous state's transaction. And that does start to build up over time because you have to keep all of those transactions because they could cheat you with any single one of those commitments, right? And that's requires quite a lot of disk space and can grow over time. And you also need to be very careful not to lose that. And once, with some changes to Bitcoin Core, there is something called L2, which is an alternate penalty mechanism. And that requires that you keep only a single transaction, which I think would be a very big change for Lightning. That is on the more technical side. In terms of scaling the Lightning network, kind of on-chain footprint and all of that, I think that as more nodes come onto the network, the reachability of nodes will become easier. So sometimes you can't really reach a node because there's only one channel to it and it's not very well managed. But as people start to learn to operate their nodes better, so manage their liquidity, keep their node online, things like that, I think that a strong routing backbone, which what we like to call it, will emerge. And that means that there's a more steady base for payments to move back and forth on. Whereas right now, there's some very good nodes on Lightning, there's some quite poor nodes on Lightning, and it's difficult to know which ones to route through. So as we get more information about performant nodes, which you learn through routing payments, and as more people start to know how to operate these nodes, I think that we'll scale a lot better.
Nice. Yeah, I also believe so. It's pretty much straightforward in the sense of adding more nodes that they can become potential nodes, potential operators, or potential routing nodes to the network will be a network effect, will be the consequence of a network effect, the fact to scale it up.
Yeah, I certainly think that also as we start to make things like liquidity management easier, if we start to learn how to automate these things a bit better, really lowering the barriers to entry to not necessarily new nodes coming onto the network, because we have quite a few, but just better quality nodes in the network. I think that'll make a huge difference for payment successes.
Absolutely. Another question here from the comments says that how can a killer application make it scale? So I think I will interpret this question as, what do you think can be a killer application for Lightning Network so it can scale?
This is such a hard question. People always ask this. My easy answer is that if I knew, I would have built it. But I guess that I still think that the main use case, or really good use case for Lightning, is actually not on the user end, but more machine to machine. So if you take a look at something like Cloudflare, they spend Lord knows how many US dollars every month employing resources just to protect people from DOS attacks. Having that buffer of 1 minute to open up a website. And I really think that where Lightning shines is its ability to be machine to machine and not have people involved. I mean, that's one of the great things about Bitcoin, is that programs can use it too. So I think something like a rate limiting API that used Lightning micropayments would be really exciting. Even things like, sometimes I look at the bots on Twitter, and I think if you had to pay 1 MSAT every time you tweeted, I would never know the cost because I don't tweet that much. But if you were building these spam bot farms, you'd suddenly face a huge upfront cost there, because that 1 MSAT would add up every time. So I think that's a really great use case for Lightning, for those very small payments instantly between APIs.
So you think, what about the paradigm, what about the pay-per-accurate use? Let's say that you have some kind of streaming service like Netflix or streaming, and or let's say you have a crowdsourcing application, so you can pay per content. What about if you can pay per that specific use content that you are consuming, or that time of hours that you are streaming, instead of a 24/7 license that you are acquiring when purchasing a package of a month? So I want to bring to the table a comparison between an accuracy payment per use versus the current traditional model, which is based on monthly payments basics.
Yeah, definitely. I mean, Lightning opens up two quite interesting possibilities with that. The first, I'd say, is just the stream per second use case, where you're streaming a video on a Lightning-based YouTube and you're paying per second. That's a really powerful use case. And also, I think helps onboard people to a service, because often when you face a payment, or even when you face a free trial for 7 days, but you have to give them your credit card, I'm always a bit reluctant to do so. Because in case I don't like it, then I'm going to have to fight my way out of the subscription. So I think that's a really great use case. But something else that we've been working on at Lightning Labs is something called LSAT. It's Lightning. Oh, I've forgotten the acronym. It's a Lightning Service Authentication Token, right? So I think this is a very cool idea. It takes a macaroon, which is really just a very fancy cookie, and it pairs it with a Lightning payment. And so when you hit a server, it will hit you with a 402 payment required, right? So it spins up a QR code and it says, hey, you need to pay a bit on Lightning to get an access token for this website. You pay your few Satoshis and it will atomically grant you a LSAT token for that website. And on that LSAT token, the way that macaroons differ from cookies is that you can grant certain permissions. So I could buy an LSAT token for 100 minutes, and the server has signed that macaroon saying that it will grant me 100 minutes. But what I can then actually do with that is say, hey, Carlos, I've got 100 minutes of Netflix. Do you want to buy 50 from me? And I can sell you 50 minutes of that 100. And grant you your own macaroon, which has a restricted set of permissions. And I think that's really cool as well, as a way to manage access. Yeah, you delegate permissions. Yeah, and there's some use cases. You can give it to your kids and say, oh, you can only watch an hour of TV this week. You can split up a Netflix service between friends. I know I've got a friend who pays for the group's Netflix subscription and he's not very happy with it. So being able to portion out permissions and perhaps not grant them if someone doesn't pay is a really nice use case there.
Interesting. And what I mean, other than for LSAT specific topics, other than timing issues that you can embed into the LSAT token, is there any other conditions you can embed into the LSAT token other than timing minutes, for example, other type of conditions you can embed into that token, authenticated token?
Yeah, so what's really nice about it is the server can decide exactly what it puts in there. So, I mean, you can put IP address in there, you can limit it to certain endpoints, you could give it an exact date where it cuts off, you could grant a token for only a specific show on a theoretical Netflix platform. So you can really, make it as fine-grained as your application requires.
Very interesting, very interesting. So how the privacy and the anonymous, the anonymous element of the actual LSAT? If you can elaborate about the anonymous element,
Yeah, so the LSAT, which is really nice, similar to LN URL, LSATs could be used for login. So instead of being identified by a email address, you're just identified by that LSAT. And because you paid it from your LND node, the information you need to log in will be stored in your payments database because you use the hash, the pre-image, so the secret that the server sent you once you paid. That is your way of authenticating. And what's nice about that is you could use one LSAT and you always have the same one and pay it and refresh it, or you could use a new LSAT every single time you log in, which is really great for privacy because they don't really know who you are. And because you're making a payment over Lightning, the server also doesn't know who the payment was received from. So they can't link that identity to your node.
Interesting. So what about the use case where, the authentication use case, where you have any client, let's say it's a game or it's any web client, where it's running a neutrino light client in the background. So if its client has their own light neutrino client running there, how would be the scenario where its neutrino light client is interacting through their LSAT for authentication purposes? Would it be possible to do in a production scale right now?
Yeah, absolutely. So in your game, what you do is say the game needs to query a server to log in. The server would present the app with an invoice. You would pay that invoice, and then the LSAT would be granted and you save it on your phone. And that's it. Then you can log in with that.
Interesting. Yeah, very, very great. So I think I have the last question here. So we've seen new developments from other layer 3 solutions such as RGB, that they are trying to do some tokenization on top of Lightning Network. And I think they are actually basing their roots from the second layer using C Lightning for doing so. And because they are somehow making some space for a third layer solution on top of it. So my question is Lightning Labs focusing or thinking, or they have any proposals, drafts, or any ideas to leave space for a third layer solution to create a tokenization layer on top of it, or maybe within the second layer, trying to integrate or adapt any kind of tokenization mechanism?
Well, I'm not familiar enough with RGB to be able to specifically comment on it. But what I would say is that at Labs, at least my perspective is that we are right now focused on building a Lightning node that just works. So we spend a lot of time making sure that our routing subsystem is really smart and aware of the state of the network, and making sure that people can manage the liquidity well. Whereas C Lightning does have what they call a plugin architecture, which I think does have quite a lot of hooks into the lower levels. So we are starting to build out some hooks like that in LND. And I'm fairly certain that layer 3 tokens could be built on top of LND right now, but I would have to understand the actual token, which unfortunately I don't.
Yeah, no, don't worry. It's a pleasure to have you here, Carla. I think from my side, I have all my questions that they were in the edge of the dynamic commitments, which is something of the more interesting things that you've been saying, because I wasn't aware you guys were also working even in a pre-draft. It's something that stands out because it's pretty new. I love that. Yeah, so from my perspective, it's been a pleasure to have you here, and you're more than welcome to be in our events in Light Nights, where we are making games and as well talking more in technical details, and it's more Bitcoin focused. And yeah, if there is any other question from the community, or Jesus, if you are here in the streaming, if you have any other questions you want to pop in and ask, feel free to do it. And I think that's pretty much it.
Oh, great. Thanks so much for having me. It's always good to chat Lightning, and I'll try and pop in on a late night game soon.
Yeah, that'd be great. That'd be great to have you and host you there. Thank you very much, Carla.
Cool. Thanks. Bye.
Thank you. Bye-bye.